Hello, this is the Buun channel. In episode 1, we built a remote accessible K3S home lab. In episode 2, we sped up the dev loop with tilt and telepresence. Today, we'll set up JupyterHub on that cluster and finish with a short demo. First, I'll explain what JupyterHub is. Then we'll install it with Helm and make sure it runs. Next, we'll discuss customization, using custom container images and JupyterHub profiles. After that, I'll talk about service integration, connecting JupyterHub to other services in the Kubernetes cluster. Finally, secrets with Vault. I'll show how to save and read secrets in a notebook, similar to cloud platforms. Let's get started. JupyterHub is a multi-user gateway for Jupyter. Many people sign in to one place. Each person gets their own Jupyter server. On Kubernetes, the hub uses a spawner to start one pod per user. Storage is persistent with a PVC, so files stay after restarts. A proxy routes traffic to each user's server. Authentication plugs in with OIDC, so we can use Keycloak. We'll walk through this flow in the demo after installation. Why it's useful for a team. First, one entry point. One place to sign in and manage. Admins, keep it simple and secure. Second, isolation and reproducibility. Each user gets a clean server that's easy to recreate or roll back. Third, profiles. Users choose an image and resources that match their work. Compared to cloud platforms, you control images, profiles, and integrations. Data stays on your network, so latency is low and compliance is simpler. For steady workloads, your own hardware can be cheaper and faster. You can share GPUs and tune storage. We'll install with Helm. In Buun stack, it's as simple as running just JupyterHub, install. First, the recipe prompts for the JupyterHub host, fqdn. It uses that to set the OAuth callback URL. Then it prepares the cluster, creates the namespace, adds the JupyterHub Helm repo, and exports a few environment variables for templating internally. Next, it creates a Keycloak client for JupyterHub with the correct callback. NFS is optional. If we enable it, it checks Longhorn, creates an NFS PV and a PVC for user volumes. After that, it renders a values.yaml from a template and installs the chart. We wait for it to become ready. At the end, we can enable Vault integration to use secrets from notebooks. We'll cover that later. All of this is documented in docs, JupyterHub.md, and automated in JupyterHub just file. If you are using Cloudflare Tunnel, add a public hostname for JupyterHub. Let's see it in action. I open the JupyterHub URL and sign in with Keycloak. I land on the server options page. On this page, options like Jupyter Notebook, Data Science Stack, and Buun Stack are profiles. Profiles are made up of 3 parts: a name, a description, and a kube spawner configuration. This configuration includes information such as container image, CPU, and memory. I'll explain more later. I choose Buun Stack and click Start. JupyterHub creates my single user pod and attaches my persistent volume. When it's ready, the launcher page appears. I click Python 3. It opens a new notebook. I'll do a quick check. Everything looks good. I'm using an NFS volume, and it's also mounted on my local machine, so I can access the same files from both places. One big advantage of JupyterHub is customization. You can create custom container images with all the libraries and tools your team needs. You can also define resource limits and requests, ensuring that users have the right amount of CPU and memory for their work. As I mentioned earlier, profiles allow users to select the environment that best fits their needs. This means you can have different profiles for data science, machine learning, or any other specific use case. A profile consists of a name, description, and a kube spawner configuration. Kube spawner starts the server pods with the specified settings. Profiles are defined in the Helm values. Here you can see the profiles. Jupyter Notebook Data Science Stack is an official Jupyter image that contains a comprehensive set of data science libraries and tools. By default, only this profile is enabled to reduce initial image pull time. Buun Stack is a custom image that includes additional libraries and tools and supports Vault integration, which I'll cover later. To use this profile, add this line to .env.local. Then, build and push the image to your container registry. All available options are defined in JupyterHub, just file. Here is a Docker file for the Buun stack profile. When you create a new profile, you can customize the Docker file to include any additional libraries or tools you need. Another key aspect of JupyterHub is its ability to integrate with other services in your Kubernetes cluster. This allows you to connect your JupyterHub environment with databases, object storage, and other tools your team uses. For example, I use a PostgreSQL database in my Jupyter notebooks. I can easily connect to it using this local address. In this setup, the environment variables Postgres host and Postgres port are set in the notebook server, so you can construct the database URL like this. For example, I will import a CSV file into the PostgreSQL database by using DuckDB. DuckDB infers the schema of the CSV file and creates the table accordingly. Let's see the data with dbgate. Then, I can load the data with DuckDB and query it using SQL. Because the database server and the JupyterHub are integrated inside the Kubernetes cluster, you can import and retrieve data with minimal latency. I am going to add more services to Buun Stack to make it useful data and AI stack in the future. Next, I'll explain how to manage secrets in this environment. Let me start with why this matters. These days, we often call LLMs like OpenAI, so we need to pass API tokens into notebooks. On Google Colab, there's a built-in secrets UI and a simple API to fetch them in code. With plain Jupyter Notebook, the common pattern is to paste secrets at runtime, for example, using getPass, which is manual and error-prone. With our stack, JupyterHub and Vault are built in, plus a small Python package. You just use SecretStore and code to safely save and load secrets. This gives you the same smooth in-a-code workflow you want. Set and get secrets right from a notebook. Each user has a private space in Vault, and tokens renew automatically, so long runs keep working. In the Vault UI, you can see and manage your secrets easily. To use this, enable Vault during install, and pick one of the Buun stack kernels. Those images include the Python package and handle Vault authentication automatically. It works like Google Colab or Databricks, where secrets are stored and loaded into code, and each user is isolated with full audit logs. Next, I'll show how this works at a high level. When JupyterHub spawns your server, it creates a user policy and token, then injects them as Notebook Vault token and Vault ADDR. SecretStore uses that token for Vault calls and renews it when TTL is low. Details and examples are in docs.jupyterhub.md. To wrap up, let me come back to why running JupyterHub on your own Kubernetes cluster is powerful. You control the images, profiles, and spawner configuration, so each team gets exactly what they need. Your data never leaves your network, which simplifies compliance and lowers latency. And you can tune performance, share GPUs, pick the right storage, and size resources for your workloads. Pre-baked images and profiles make environments one click. Each user gets an isolated, reproducible server that's easy to roll forward or back. And because everything runs inside the cluster, notebooks can talk directly to services like Postgres or object storage using simple in-a-cluster addresses. Authentication flows through Keycloak and secrets go through Vault, with end-to-end per-user isolation. For a home lab or dev learning setup, owning simple monitoring and backups is a plus. And you avoid ongoing cloud costs for steady, long-running work. That's it for today. We set up a multi-user JupyterHub on Kubernetes and made it practical for teams. We looked at what JupyterHub is, installed it with Helm using the just task, enabled profiles and custom images, connected to in-a-cluster services like Postgres, and used Vault to manage secrets directly from notebooks. Thanks for watching.